I'm sure we'll probably have some more stragglers come up from breakfast, but let's get going anyway. So I'm Chris Saxon. I'm part of Stephen Feuerstein's Oracle Developer Advocate team, and along with Maria Colgan and Connor McDonald, part of the Answer team on Ask Tom. It's our job to help you get the best out of the Oracle database and hopefully have a little bit of fun while doing so. So with that in mind, what I'm going to do is I'm going to do some SQL Magic. So things that look like magic tricks using SQL and the Oracle database. But of course, they're not magic really, and I'm not a real magician. I'm going to explain how the tricks are done, so hopefully you can learn something and do your own magic when you get back to work. So to begin with, what I'm going to do is a SQL version of kind of a classic magic trick. So I'm sure you've all seen like the sawing a lady in half trick, haven't you? The magician gets their assistant, puts them in a box, and seems to pull them to pieces. So what I want to do is a SQL version of that trick. Obviously, I'm not going to saw any people in half. What I'm going to do is get a SQL statement and rip that in half, and hopefully it'll still continue to work. So before we begin, nothing up my sleeve, so there are no other tables in this schema. I've got a simple join between employees and departments, and unsurprisingly, that returns a whole bunch of rows. So what I'm going to do now is just rip that statement right down the middle, and hopefully we will still get a working SQL statement. So if I come down and scroll this across like this, so we've divided it right down the middle. Let's just get rid of that, so in case you think I'm pinning anything here. Okay, ready, and here we go. And yep, we've still got exactly the same results from that statement. Now, at this point, some of you are probably thinking, well, I've just like hacked the HR employees table, right, to make it look like that. Nope. Let's take a look at it. It's still the same HR employees table we all know and love. So that SQL statement is still really returning the same results as it did previously. But I want to go further. This is, a real object name. I want to go further and rip it again. So let's just divide it again. We'll bring this over here so we get even further in half. So we just got select from HR.d. Okay, ready? Here we go. And yes, we've still got exactly the same results, even though it's a completely different query. Now you might be going, well, maybe, okay, you just created another object. There's no other tables. Maybe it's a view or a synonym or something like that. Let's take a look. Nope, there are no other objects in the HR schema or my schema other than the standard one you get. So there's no HR.e object there, right? But this still looks like it could be a real SQL statement, right? This looks like it's kind of valid, not exactly, but I want to go further. I want to take this down to just select from and on, okay? Let's see, here we go. We're going to get it just so we're selecting select from and on. This couldn't possibly work, right? Yeah? No? Okay, here we go. Let's see. Hopefully, and 1, 2, 3, and yes, we've still got exactly the same results as we did originally, even though I've basically got a kind of nonsense SQL statement here, right? Pretty cool. So, of course, at the end, the magician has to kind of put their assistant back together and prove that they're still all living. So let's put the SQL statement back as it was. And what do we find? Well, that's magic. So, what's going on here? Has anyone got an idea? Anyone got a clue as to what I might have done here? No? No, fair enough. So what I've done is taken advantage of a new feature that came in 12c. That's the SQL Translation Framework. What this enables you to do is create what are called translation profiles. And within a profile, you can associate the text that you send to the database with a completely different SQL statement. So basically what you can do is map some SQL text to something else. So that's what I've done. I've got these statements here and mapped them to something else. So if we take a look over here, we enable it. I've created these SQL translation profiles, so you can enable them at the session level. So if I disable this like that, and try and run this select from and on, you get what we would expect, complete nonsense. So you have to enable this profile to use it. If I do it, I create my saw profile like this and run again, we find that we get the original statement. So what I've done is I've mapped this text back to that original join. Do note it does have to be an exact text match. So if I start putting some spaces in here, it's no longer going to work. So what I've mapped in the database has to be an exact match white space, case, and so on. So at this point, I'm sure some of you are looking at this and thinking, well, okay, it's kind of maybe a neat magic trick. It's a great way to do things like play some practical jokes on your colleagues so that you can do. But what purpose does this have? What real use is this? Why does this feature exist? So to explain that, a little bit of background. So a while ago, a colleague reached out to me, and they had this statement in SQL Server. And it was running in SQL Server, and they wanted to get it to work in Oracle. Now, if you don't look too hard, this all looks okay. Whoop. Oh, what have I done there? I've kicked the magic of kicking the screen out. There we go. All right, then. So I've got I've got my statement here. But you can see there's a whole bunch of things which exist in SQL Server but don't exist in Oracle. So date add, convert, get date. We got to select here without from. Pretty much every aspect of the SQL statement you've got to change to get it to work in SQL Server. So what does this do? Well, it's generating a month's worth of dates. So the Oracle equivalent looks something a little bit like this. So we can see we got a whole bunch of rows there. And that's assuming you're on more recent versions. You know, going back a bit further, you have to do something like the connect by level trick. So this could potentially be a problem. So if you've got an application that currently runs on SQL Server and you want to migrate it to Oracle, there's potentially a lot of SQL statements you've got to go and change. So you've got to go and map them to Oracle database. What the SQL translation framework was introduced to do was to help ease that migration. So you can do that mapping in the database rather than having to change your code. How do you do it? Well, first thing you need to do is create your profile. So I'll call it SQL Server, and then register what those translations are. So here's my original statement, and here's the new statement that I want to run. So we put that in. Now, at this point, everything's in place, but it's not actually active, because if I try and run this, we'll get the missing expression error. So it's not actually active. It's in place, but it's not active. You do that by altering the session. So we saw a bit earlier where I disabled it. So we set translation profile to SQL Server. You also have to set this slightly cryptic 10601 event. I've already done that. But once we've done that, you can now get SQL Server, SQL running in Oracle database. Hooray! Fantastic. Now, this is kind of cool, kind of neat. But if you think about your typical application, there's hundreds, maybe even thousands of different SQL statements, right? Now, you might think to yourself, okay, this is nice, but if you have to go through every single one of those, figure out if it works on Oracle, if it doesn't come up with the equivalent and register the profile, well, you kind of may as well have just rewritten your application anyway, right? So fortunately, we've thought of that. As part of the SQL translation framework, there's a bunch of libraries. So there's a whole bunch of jars you can install in your database, and they will map SQL Server statements to Oracle database for you. So that does, and we say we fully support SQL Server, so hopefully you can just kind of lift and shift it, and you don't actually have to change any of your SQL statements to get them working in Oracle database. So we can see if we've got something that you kind of might see a lot in SQL Server, so get date. So the Oracle equivalent of this would be exactly select sysdate from Joule. So currently at the moment it's not working because I haven't enabled the profile. So we enable the profile, run it, still doesn't work because I haven't set this lovely event. That's going to take a second or two to run. But once it's done that, the framework's kind of smart enough to be able to intercept these on the fly and rewrite them for you. So we'll give that a second to run, and hopefully we'll see that it actually works. There we go, and here we go. So let's check it out. Select get date. Yes. So we can see we've got that query running. So what's actually going on here? Well, you can see we've got this $mapped SQL text view. We run that. You can find the text that was sent to the database, and you can find what it actually was mapped to. So potentially, this is the kind of thing which could be a little bit confusing. You know, you're kind of mapping it, and either maybe something's gone wrong or something's not quite what you'd expect. You can see what's going on here. The important thing to note here is this essentially sits in front of the database, the translation framework. So it intercepts that statement, rewrites it, and then sends that rewritten statement to the normal database processing, so the optimizer processing, figuring out what to do, and so on. Okay, so this is pretty cool. Easier way to migrate from Oracle SQL Server to Oracle Database. We've also got full support for Sybase, limited support for DB2. But how many people routinely move applications between databases? So who's ever migrated an application from any database to any database? Not just SQL Server to Oracle. Could be the other way. Okay, so a few of you. How many of you have done that in the past year? No, half a hand there. How many of you have had to deal with performance problems in the past year of any kind? Yeah, so most of us, right? So migrating between databases is a relatively rare occurrence. It's something I'm sure there's some consultants out there who do it all the time, but for most of us, we don't do it that often. Dealing with performance issues is a much more day-to-day issue. And sometimes when you've got a slow SQL statement, the way to make real meaningful performance gains is to physically rewrite it. Maybe you're accessing the same table once, rewrite it so only accesses the same table twice, I should say, rewrite it so only use it once. Maybe to use analytic functions or something like that. So that's all very well and good. You've got your slow SQL statement that your users are complaining about. They've raised a ticket. You come up with a new, improved, faster SQL statement. Now you just got to kind of get it into production, right? Now, hopefully, you've got nice, slick deployment processes where you work, where you can get it out and you can be deployed just a few days later. No, I appreciate it. Not everywhere has quite that slick a process. Some of you might have a lot of red tape, bureaucracy you kind of got to go through before you can get something released, or you might have fixed release windows. You know, do things once a month, a couple of times a year, or something like that. That's potentially a long time to make people have to wait, particularly if you've got an improvement. And that assumes it's like an internal application. Say this is a third-party application. You've identified improvement for them. You've got to send that to them. You've got to wait for their patching and release schedule. You could be waiting a really long time to get this change into production. SQL Translation Framework enables a temporary patching solution. So if you need like a very short-term hot fix to actually get things up and running quickly so you don't have to wait for your full application release, then you can use this. Now, this is something we actually endorse. There's this line in the documentation kind of to that effect saying, you know, we recognize you might want to use this for performance patching or getting correct results. So it is available to you. I would recommend you only use this as a temporary workaround. You know, it's potentially quite confusing if it's always there permanently, but it is available to you. So that was the SQL Translation Framework. It enables you to map SQL text that's sent to the database to something completely different. As we saw, if you ever want to play a practical joke on your colleagues, maybe a nice way to do it. Do note you do have to have particular permissions to do this. So as long as you're not granting DBA to everyone in the world, you should be fine. No one unlikely to get in and just do whatever they want. Primarily designed to help migrate applications to Oracle database, but it potentially could be useful to you when you are, if you have to deal with performance issues or you need a temporary fix quickly where you can't wait for an application release. Any questions on that before we move on? So the things you need to do is you need to give the permissions to, if you're creating your own ones with the packages, you need the permissions to execute on those packages and to run those. Then you need to actually deploy the changes with the packages. Or if you want the translation framework for SQL Server, there's a whole bunch of jars that you need to install. There's actually a thing in SQL Developer to do it for you. I forget exactly where it is, but there's somewhere where you can just say install the translation framework. And then you need to make sure you're setting this translation profile. So you can do that with a logon trigger. You can bind it to your database service. So there's a number of ways to do that. So you do need to, even if everything's in place, you still need to enable it at the session level to make it work. Does that answer your question? Cool. Any other questions on this before we move on? No? Fine. Okay, cool. Let's move on. Let's do next thing. So what I've got here, I'm going to have a table of people, and it's going to store their birth date and their astrological star sign, or that's the right one, isn't it? Not, yeah, zodiac star sign. So, Cancer, Libra, Leo, and so on. Now, obviously, there's a relationship between when someone was born and what their star sign is. So hopefully, yeah, that's completed now. Let's have a look at the table. So we can see we got our 3 data sisters, and they're all born in January. What I want to do is just update one column and have the value in another column change at the same time. But I want to do that without having any triggers. So, as I say, nothing up my sleeve. There are no triggers in this schema anywhere, so there's no triggers on that table. And it's also not a view, so I haven't just kind of selected the information over the top of it. So what I'm going to do is update Sally's birth date, move her to October, and hopefully her star sign will change at the same time. So as we can see at the moment, she's born in January, Capricorn. So if we change it, here we go, ready, and update, and there we go. Yep, so she's moved to Libra. So that data has changed, even though there's no trigger. Only updated one column, value in another has changed. Let's go on, let's see what happens. We'll change Lisa, move her to be born in February. Do that, run, and what's happened? Now Pisces. So I just updated one column, the other one changed. Now it's not just updating data, I also want to do it when I'm inserting data. So I only want to insert the names and date of birth. I don't want to insert the value for their star sign. I want to calculate that on the fly. So put me in, and yes, so you can see it's set Capricorn. Now you might think, okay, maybe I'll just set a default for that, so that's what appears. Let's run it again, different date of birth, baby Saxon born in May, and take a look, and yep, they're in Taurus. So it's not just that I've put a default column on that column. It really is setting that based on the other value. So I've updated, set the values in one column, but the values in another have changed, and it's not due to the fact being a trigger. What's going on here? Virtual column, yes. So, how many of you are familiar with virtual columns? A couple of you, not many. Okay. So, virtual columns is something that came in 11G. And if we take a look at the table DDL like this, what I've got here, we've got the zodiac sign, and you can see it's generated always as this function. So what that means is, instead of storing that data, every time you query the table, it's calculating that, running that function to get the results. So we kind of store the calculation so the data stays in sync. And this kind of helps solve the kind of classic kind of third normal form problem debate. So we've got a relationship between these two columns. And if you're saying things are in pure third normal form, you say if a value depends on another value that's not the primary key, it shouldn't be in that table. You shouldn't store it in that table. So we've got the birth date. There's an implication if we change that value, you should also change the zodiac sign, right? And third normal form, we say, okay, you should not store that in this table because you've got to maintain them. Now, the classic way to solve this is to split them out, have a separate dates table. Now, I think there's still a lot kind of going for this approach. It's still worth investigating, but it may be a bit impractical in some scenarios. For example, let's say this is your employee's database. You've got a couple of thousand people. That dates table needs to have 80 plus years worth of rows in there to cover the fact for every possible combination of when someone might be born. So you've got a lookup table which is, order of magnitude larger than the main table itself. It seems a bit strange, right? I still think in this scenario that might be worth doing. There's reasons to have a dates table beyond this. But there's other scenarios. Let's say your zodiac sign was not just based on the day and month, but the actual second you were born. That lookup table would have to be absolutely colossal, and it's kind of impractical at that point to do it. So this is a good approach, but it has limitations. So another approach people say is, okay, rather than storing it in the table directly, rather than storing this data, what we can do is calculate it on the fly using a view. So what you can do is create a view like this, and say that when people want to use this, they can query the view instead. Now, this is nice, this works, but there's a few kind of gotchas and limitations. First thing is you need to make sure everyone uses that view. So all the code accesses your view. So that's doable, but you need to make sure you've got good processes in place so that no one's accessing the table directly, or at least not in particular circumstances, special circumstances. But using a virtual column has a couple of other advantages over a view as well. What are they? Well, first up, you can gather statistics on the virtual column itself. So we can see here the database has stats about people's zodiac sign. So this can help the optimizer come up with a better execution plan. So if you've got queries against that virtual column, the optimizer's got better information when it's a virtual column versus when it's a view in your table, when it's a view. So hopefully it can come up with better plans. Second thing is you can actually create constraints on it. So, you can then validate, this is a further validation that you've got your function correct. If you try, it comes up with something invalid, then you'll get that check constraint error and people will be informed about it. So you can do more to ensure your data quality over putting it in the view. There's another thing as well. So function-based indexes. So let's say we want to search for people's full name. So we want to see their full name and we want to do it in uppercase. So what we can do is create a virtual column like that. And we can now index it. So this now simplifies our queries. We can now query that full name column and Oracle will use that index. So we've got the function-based index, but we don't have, and I've pulled the cable out again, sorry about that. Keeps treading on things here. So we've got the, this simplifies your queries. You don't have to think about exactly how have we done it. Have we done it upper or have we done it lower? What's the formatting of it? In order to use the function-based index, you have to match exactly. We could have written the query, the thing to get people in upper like this, or I could have done something a bit like this. And it can be tricky to make sure everyone writes the function in exactly the same way. By making it a virtual column, you just say, use this column. And they don't even necessarily need to know it's based on a function, but it is a virtual column. And there is actually another advantage. If you have got existing code like this, so let's say you've got this query in your database anyway, but you want to move to the virtual column, well, even if you do this, Oracle can still actually use that index I've just created, and you can see that there. So it's created that index I've created on the virtual column, even though I haven't actually explicitly referenced it in my query. So it's potentially quite useful. So it's kind of backwards compatible with stuff you've got already, making it making it easier to kind of retrofit into your application. However, there are a few things you need to be aware of. First up, you cannot explicitly set the values. So if you try and do an update, and it's not giving me an error for some reason, unfortunately. Let's face it, these won't work, and even if we specify null, so if I query the people table itself, we'll see that those values haven't gone in. Okay, that's because you cannot specify a value for a virtual column. Now, this might be a problem if you've got tools or frameworks which automatically update or insert all the values for all your columns. So you need to check and make sure that you're not in that situation. Most of them, either toggle it so that you explicitly set them or disable that somehow. So that's an important thing to be aware of. Second thing to be aware of is that the function must be deterministic. So given the same input, you must get the same output. Now, something like how old you are is a non-deterministic thing. Unfortunately, every year, we all get a year older, right? Sad but true. So if we try and create our function to do that and add it to the table, and I've lost my errors for some reason still, but if we look at the table itself, we will see there is no age in years column. That's because this is a non-deterministic function. Now, thing is with deterministic functions in Oracle, it doesn't actually know it doesn't have a way to check and validate, is this really deterministic or not? The way you tell it it's deterministic is you just stick this deterministic keyword in. So what you can do is you can kind of cheat and say, yeah, I know it's non-deterministic, but we'll tell Oracle it's deterministic just by sticking this keyword in. So we can do that, stick this in, and we can now add the column, and there it is. So we now got the age in years. Be very, very careful before going down this route, because now you are lying to Oracle. You've told it that something is deterministic that isn't. This can lead to unexpected results. Let's take a look and see. So let's index that age in years column. I'm going to use this. Who here knows about this fixed date thing? Oh, one hand, yeah. So this is something you can actually use to set sysdate to a particular point in time. So what I'm going to do is kind of fast forward to the end of the year like this. So we've set the fixed date to December. So I'll just pin that, and we see that Sally is 42, but by the end of the year, she'll be 43. She'll be a little bit older. So we can see she's now 43. What's going to happen when I run this query to find out how many people are 43? What result am I going to get? What result should I get? Yeah. So, but let's take a look and see what actually happens. I get no results. If I search for where it's 42, I get the original results. I get the wrong results. So why has this happened? Well, the index stores the value at the time you created the index, or you inserted the row, and it stays for that value. It doesn't change as kind of time moves on or other things happen. So you can see here, this is just one example of somewhere where I've lied to Oracle. I've said something that's deterministic that's not, and now I've got incorrect results. So yes, you can do it, but think really, really hard before actually doing this. Okay? So I'll just disable that. So what's the solution in this case? Well, you're back to the place where you create a view, and then you point people back at the view. So any questions on that before we move on? Well, it's a virtual column, so I can't. A birthday? No, that's the thing. Because it's the value that's indexed and it's a different column, it's not keeping it up to date. Yeah, exactly. So, yeah. Mm. Yeah. Now, if you rebuilt the index or you dropped and recreate it, it would pick up the new values. But just your normal DML is not going to change that. So, and this is a fairly simple example. You know, you can imagine in more kind of complex examples, all sorts of weird stuff can happen. And this is just one scenario. There are other scenarios where you can end up with incorrect results because you've told it something that's deterministic that isn't. Okay? Yep, question? So I haven't benchmarked them specifically. I mean, the thing to remember is with the virtual column, it is calculating it every single time. So again, there's a trade-off. If that, yeah, it's only when it. Exactly. It's only when you select that column specifically. So if you don't select the column, it doesn't run the function. Now, it's one of those things that will depend. You know, if that function is really expensive, maybe you're doing some advanced mathematical calculations and you're selecting a large amount of data, maybe it will add enough overhead that you kind of go, well, I've got to make that trade-off. I will physically store it and update it with a trigger or something like that. But just in kind of informal testing, I've never noticed this add specific overhead, but it's entirely case dependent. Benchmark and test if you're worried about performance yourself. Mm. Mm. Yep. Yeah. Yeah, probably the materialized view would still be better, but again, benchmark, and of course there's other benefits you get from the materialized view, isn't there? Because it's pre-computing your join, any aggregations, it's also pre-computing those as well. So yeah, you got to test and check your trade-offs. There was a question over here, yeah? Create table as? So let's see what you mean if we just do kind of like create table T as select from people, you mean? Let's just see. Let's see what happens. Go on, let's give it a go. It's taking a second or so to run. Come on. I've hit the wrong button. I hit the print button rather than the shortcut. There we go. So actually, are people familiar with those? So you can see it's selected, it's got everything. So, it's just worked. But now they are real physical columns. They're not virtual columns anymore. Yeah, they're not virtual columns in the, yeah. Can you make it a virtual column as part of the create table as select? Is that your question? Or not that I'm aware of? Anyone else? Got? Yeah. Right, yeah. Yeah, I think you just need to make sure you're careful in that scenario and not doing anything. Yeah? Okay. Okay. Any last question before we move on? No. Okay, cool. So what I'm going to do next is a card trick. So for this, I'm going to need a volunteer. While I just set this up. So we've got a deck of cards here. So we've got 52 a pack of cards, which are all the rows. And what I want to do is get someone up to come pick a card for me. Come on. Someone. You. Oh, we've got a lady coming over here. So come on. Thank you. Big round of applause for her. Okay. Go on. All right, come on. So come here. Okay, Rose. Hi, Rose. So what I'm going to ask you to do is choose a card. And the way you're going to choose a card is you'll copy-paste the value and the suit into these here. So if you wanted, say, the 5 of clubs, you just copy-paste those in like that, okay? Or I'll just undo that. So you happy?
Okay.
And then once you've done that, run the statement,
okay,
and then roll it back. Okay? You happy you know what you're doing?
I think so.
You think so? All right, then. So just give her a minute. So I'm not going to look and see what she's doing. And what I'm going to try and do is figure out what card she's chosen. So just give her a minute. So she's choosing the card, able to pick something. But I'll see if I can psychically read her mind. So I don't know, is Darren Brown popular over here in the US? Getting some blanks. No, he's a kind of a psychological illusionist that we have in the UK. He's very popular, and the idea is he read people's minds. So I'll see if I can do that to figure out which cards Rose has chosen. Are we doing all right there?
Yep.
Is it? Yeah. So delete. Just. Okay. So it's all gone. All right then. So it said one row updated.
Yeah.
I dropped database. All right, okay, we okay? So I can't say, yeah, one row updated. So just stay here. What I'm going to try and do is read your mind and figure out which card you've chosen. So I just want you to come close.
Okay.
Come here. So it's all right, it's okay. So what we'll need you to do is just think about that card. I want you to picture it in your mind and repeat it to yourself over and over and just kind of really visualize exactly what that card is. So just come a little bit closer. So, yeah, it's okay. Now, I kind of, yeah. It's like Larry gave me permission to be nice to people, so it's all right. So I just need you to really visualize in your mind and get a really clear picture of what that card is. Keep repeating the value, so it's kind of like on the tip of your tongue. And I'm going to see if I can just pick it up, and I'm going to see if I can get it to go all the way down my hand and into the computer. Okay, right, are we ready? Okay, just really picture it really clearly. If you got it, you're going over and over in your mind, thinking. Really repeat it yourself. Okay, I think we're getting it. Okay, ready? And was that your card?
Yeah.
Thank you. Right. Thank you. Go on. Thank you, Rose. So, what's going on here? It's magic, right? It's magic. Well, it's magic. I'll just run this query here. We can see that I've done a row num equals 1, and it's the card that's come back. Well, how did I know? How has that happened? How did I know that that card's going to come back versus anything else? Well, originally, they were sorted in some kind of random order. So how do I know that's going to be top? She could have picked any card. I didn't. Last updated? Okay, so let's scroll down a bit. Let's scroll down a bit and see what's going on here. So you can see there's only 3 columns here, but I'm going to select 4. And we can see this 4th column has magically appeared. So what's going on here? Well, this is another new thing we've introduced in 12c called invisible columns. These are columns which don't appear when you do generic table access, so things like select stars and describes and so on. But they're still really physically in the table. And we can see here that this is, we've got this hidden column, that PK. So I can select it out, but I have to explicitly name it. And it's got the value -1. So well, how does that help? What's going on? So I'm sure you clearly guessed, or might think, being very naughty, had some triggers on this table. And of course, the trigger sets this PK value to -1 in the background. But again, how does that help us? How does that make sure that this is going to be the top value in the table? Well, what this is an index organized table. So with an index organized table, well, with a regular table, when you create it by default, you've got your primary key and your data, and they're 2 separate data structures. What an index organized table does is combine those 2 data structures into 1. So the table effectively is the primary key. Now, primary keys are supported by an index, and that index is a sorted data structure. So values have to go in the correct location in the index. By setting the value of this primary key, so I've got my primary key, which is actually these 3 columns here. So I've kind of created a fake primary key. The real primary key is just these 2. But by making PK that leading column of that primary key, it now has to physically move it from wherever it happens to be in the table to right at the start, because -1 is before 0. So it sorts it to the top of the table. How is that useful? What's the point of index organized tables? Well, there's a couple of things. Because it's now 1 data structure, if you've got a small kind of lookup table, so your statuses, your descriptions and so on, which you only ever query by primary key, you've now only got to look at one thing. You've just got to look at the index versus going from the index to the table. So potentially you're saving yourself a tiny little bit of I/O. But they can also help in situations where you've got compound primary keys. So master detail relationships, orders to order items, meetings to the people who attend them, a flight itinerary to all the flights within them. They'll have the order ID or whatever it is as part of the primary key, and then you've got all the items as the second column in the primary key. By making that an index organized table, you guarantee that all the rows with the same order ID are kind of next to each other in the table. So they're all in the same location. So it's kind of like, you're all kind of scattered in your seats around here in the room. It's a bit like saying, I'm going to sort you all by whichever state you've come from or which country and pack you. So everyone from Texas is all next to each other, and everyone from wherever else in the country or world you've come from. So rather than me kind of saying who's from Texas and you being all over the place, you're all sitting right next to each other. This can potentially be a big performance gain because you're having to do less I/O. You just go to one location versus all over the whole table. Now, do note, I've kind of implied that this sorts things here. So it's sorted in the data structure, but it doesn't guarantee that you will get your results in that particular order. Make sure you've got an order by. I've kind of cheated a bit. I've taken advantage of this fact that I know this all fits in one block so that it's all in the same location. Just because you use an index or organized table doesn't mean you can ignore your order by. Okay, so I was very naughty. I had a trigger on the table to update that hidden column to set it to a lower value so it's sorted to the top of the table. And that's how we could find it and project it on. Any questions on that before we move on? That's all I'm going to tell you. No, I've got to keep some secrets. Go on. Go on at the back. Well, maybe later. Go on. Yes. So yes, I submitted a job as part of that, which then maintained it later. So like I said, I was very naughty. The rule thing to learn from this: don't use triggers, right? So we've got a question at the back there. Yeah, sure. Yeah. So let's bring this over. Table. Like that. So you can see it looks a little bit funny in the browser. So you can see already that it's an index organized table. Let's just bring it. It'll take a second or so to come up. Let's get the SQL. Is there anything particular looking for in the DDL, or just? Yeah. Come on. So it's just, if you want to make things invisible, it's just the invisible keyword, and you can alter existing columns to do it. The primary purpose, or the main purpose, as far as my opinion, is to help de-risk release changes. So dropping a column is a one-way operation. If you drop a column, you can't get it back without going to backup or something like that. You've got to restore it. That's kind of scary, and pretty much everywhere I've worked, you end up with deprecated columns that are supposed to be dropped, but no one's brave enough to do it because they're not sure what it's going to break. By setting something to invisible, you kind of give yourself a grace period. If there are any select stars which require it, they are going to continue to, or you'll find out, and you can quickly roll back by just making it visible again. And of course, if it is invisible, people are less likely to develop new code that relies on it. So it helps kind of de-risk deprecating columns, removing them. Potentially as well, when you're adding new columns, if you've got old legacy code which does select stars, which you can't change and isn't going to pick up that column, you can do things like that. So that's the primary use I see. So you can see there's the invisible, and there's the organization index, which does that. Okay, any final question? Oh, one last question, yeah? So, sorry, could you repeat that, please? Percentage record type, yes. Yes, so if you've got percent row type, it will not appear. So, like I say, any generic access, such as percent row type, describe, select star, it won't appear on those. So you're doing like selecting a row type and doing update set row, something like that, it won't appear. So you're okay in those situations. Okay, so we got one last trick. Let's finish up. Okay, so to finish up, what I've got here is I've got a table of dates, magic dates, as I say. Why? Well, the data type of the column is a number. So someone, instead of using a real date, has used a number. Now, there's a lot of problems with that, the most obvious of which is it allows you to store things which maybe look possibly like dates, so year, month, day formats, and things which definitely aren't dates. So this isn't good. So what I want to do is I want to change this column from a number to a date. But I want to do it just by running DML, so just by doing selects and inserts. I don't want to do any DDL, no alter tables whatsoever. So prove there's nothing up my sleeve. Let's set the NLS date format. So the numbers are in year, month, day format. NLS date is day, month, year format. What I'm going to do, I'm going to insert a number like that. So January last year. Okay, here we go. Hopefully, we can get this. Hopefully, this is going to work, and hopefully, it will become a date. Okay, we ready for this? 3, 2, 1, and yes. So we can see we've got it to be a date. Now, just to prove, I'm not doing anything funky with the formatting. If we compare it to a date, queries it back. If we compare it to a number, we get an exception. So Oracle can't do that implicit conversion. So it really is a date. So I've converted that new number to a date. Let's keep going. So we'll put another value in, query, and we'll take a look. And
sorry about this. I think something's gone wrong.
yeah, it's like live demos, right? Things always break. Let's just double check. So we compare it to a date. Okay, that doesn't work. Compare it to a number. That doesn't work either. Let's just save that. All right. I'll try again. Let's try again and see what's going on. Okay. Let's try again. Here we go. In it goes. All right. Hopefully it'll work this time. Ready? 3, 2, 1, and yes! We're back to being dates again. Okay, cool. I think we're back on track. Okay, let's keep going. Let's put another value in and select again, and back to a number again. Okay, so something a bit fishy is going on. And you know what I'll do? I'll use a magic date. So people get scared of null, so they pick some kind of magic value, 31st of December, 99, or some other distant, far-off date, which can never possibly happen. Let's try that. Let's try and see if we can put a magic date in, and let's see if that will fix it. Okay, so in it goes. Okay, here we go. Ready? And 3, 2, 1, and what? We're a string now. Okay, this is just getting silly. What's going on? All right, I think inserts aren't cutting it. I'm going to have to go for an update. Let's do an update. Let's see if I can update it and force it to become a date. Okay, ready? We all ready for this? Ready? Okay. By the power of COD, I compel you, become a date. And let's just check. Yes, everything's a date, and then dates go in, number, that doesn't go in, string doesn't go in, save it, and everything's still a date. Hooray! Okay. So, what's going on? I started with a number, then we went to a date, then we had a bit of back and forth for that, went to a string, and ended up finally at last back with the date again. What? Who knows? What's going on? Anyone got no idea? That's a good question. Okay. All right then. So what I've done here is I've used something came in 11.2. That's edition-based redefinition. So before I explain exactly what's going on here, a bit of background about edition-based redefinition / EBR, as it's more easily commonly known, and what it is. So when you're trying to patch your application, a database application, and you want to do it with 0 downtime, potentially there's a lot of problems. In the kind of generic case, the old version and the new version of your application may be incompatible. So if someone's using your application, you release your change, they refresh the page, and everything breaks because something incompatible has happened between them. So it is possible to write your releases so you never get in this scenario. You always create new objects. You never actually change something. You just create a new function or procedure or a new package or whatever. But that's clunky and hard to manage. But even if you make your release so it's always backwards compatible, so you're not going to unexpectedly break something, things can still go wrong partway through. So your typical database release doesn't just change one thing. You might create or alter a couple of tables, release a few packages, maybe update some rows, so on. And for the duration of your release, your application is in an unknown state. Anyone who happens to be unlucky enough to use the application in that period of time while the release is in progress, you don't know what's going to happen. Packages could be invalid, things could be wrong, things could be behaving unexpectedly, and it's really difficult to test and maintain and ensure and validate that you don't get around this. So the simple approach is just kind of take an outage, don't let anyone use the application for the time while the database release takes place. But not all of us have that luxury. I mean, how many people here can take outages regularly with their application? A few people. Okay. It's increasingly becoming that applications have to be available 24/7, and maybe you can get an outage, but you have to schedule it in advance. Maybe once a month if you're lucky. I know places which only allow outages twice a year and so on. So this is a problem. And it's a problem that people like in the middle tier world have solved ages ago. How? Well, by having two versions of your application at the same time. What you do is you've got your live application that the people are using. You create a new application, spin up a new application server or whatever, deploy your new code to that, make sure it works, check everything's okay. When you're sure you're happy that everything is fine, you can then have some process to migrate people from the old application to the new. And if you've got some funky load balancing or whatever, you can do that without an outage. But you can't do that in the database, right? As soon as you recompile a package, it's visible to everyone. You don't have your own private working area where you can deploy your changes, check that they work, make sure everything's valid. You actually deployed the correct code, no unexpected bugs, made it through Q&A, and so on. It'd be really nice if you could have that. If you could have your own private working area in the database where you can deploy your changes while the old version is still active. And that's the essential principle behind EBR. What it does is it extends the namespace. So previously, if you wanted to fully qualify an object, it was schema name.object name. So Chris.customerspackage or whatever. EBR extends the namespace and puts what's called an addition before the schema. So it would now be addition name.schema name.object name. So now you can have two copies of that customers package in the same schema in the same database. So you can have two versions of them side by side, the live version people are using, and the new version that you're testing and frantically checking and making sure is actually all okay. So that's kind of the background and the principle behind this. Let's look at how precisely this works and how it actually enabled this, the magic trick here. So what I've got in the database are 3 additions. So $, base, all versions of all your databases will have this, whether you use EBR or not. So starting from 11.2, everything will have an $, base. And these are the release editions I've created, so E1 and E2. Now, one thing to note is, although this extends the namespace, you cannot explicitly specify it. It's just part of your session settings. So you can see here, if I do this, we can see I'm currently in edition E1. If I select from the table, I've got the dates. If I try and explicitly specify those editions, I get an error. So we'll do this, all those errors. You have to set it. So you can do that by doing an alter session like this. We can see we get the different numbers, then we've got the dates, then we've got the strings at last. So you can do this as an alter session. You can also, as part of your connect string, so JDBC has a connection property. There's various other ways you can do it. So it's implicit in your session. Okay. So what did I do and how did I create this magic dates table? So if we just come up here and take a look at it, we'll see that, well, actually, there is no magic dates table in the schema. Why is that? Well, there are still some objects that you can only have one of in a particular schema. And those are primarily things that store data. So tables, indexes, materialized views. There are a couple of other things depending on your version as well. So we take a look at this table, and that will come up in a sec. And we'll see that this table actually has 3 columns in it. I'll just query the base table directly. So we just got the 3 columns in this table, right, with the different values. So what have I done? Well, what I've done is created what are called additioning views on top of the table. And the principle is when you use this, you're supposed to get your application to use the additioning views rather than the tables themselves. Now, why do we use an additioning view? Why do we do that rather than a regular view? Well, there's a couple of reasons. First up, additioning view has only allows you to do selecting and renaming of objects, okay? So you can't do things like have a where clause. You can't have functions on your columns and so on. Why? Well, then that guarantees that whatever DML you could run against the base table, you can also run against the view. You know, if you've got a where clause, you might find that it behaves differently. If you've got a function, again, it can behave differently. So this guarantees that it's effectively transparent to your application. So you can see here what I've done is in each different edition, I've selected a different column, but just renamed it back to the original column, so it appeared like the same thing. So that's the first special property of additioning views. The second special property is you can create on them what's called a cross-addition trigger. So this is a new type of trigger that came in to support EBR. Now this is the only way that you can look into a different addition. So you can look into the addition behind yourself or ahead of yourself. So you can look forwards or backwards one. And that's essentially, I'm pulling the cable out again. I need to watch where I'm walking a bit more. So that's basically what's happening here. When I'm in the edition where we're seeing the numbers, I've got cross-addition trigger, which is to dating it and setting it in the other column. So we're keeping the data in sync. So this means that I can deploy this change, have people still on the old edition, and populate that new column while they are adding new values. So everything stays in sync. So at the time when I'm happy that that release has worked and everything's fine, I can have a cutover and all that data is present. I don't have to do some kind of update at that particular point to set all kind of null columns and things like that. Do note, EBR is just an enabling technology. If you want true downtime, zero downtime releases, you've got to sort out your network. You've got to figure out a load balancing solution to switch people from old editions to new. You can't log in as sysdba and ping people to new editions. They have to physically disconnect and reconnect. So you need something outside of your database to do that. But that was EBR. It helps enable zero downtime releases. I had 3 editions in my database here, and that's how I was able to expose different columns. We've only got 1 minute left, so I've probably got time for maybe one question on that. No, it's a big topic. If you want to speak about that or anything else, feel free to come up to me. I know it's early. I'm glad that so many of you came to see this. Thank you for joining me. I'm Chris Saxon. Enjoy the rest of Kscope.